Welcome to my class. In this particular session, we will talk about TCP/IP. TCP refers to Transmission Control Protocol and IP refers to Internet Protocol. Both these protocols are in the form of software. The software that is responsible for making the Internet function efficiently is TCP/IP. In 1975, Stanford University's Winton Cerf developed a communication protocol called TCP and an addressing protocol called IP. Internet being a packet switching network, the message is transmitted by dividing it into small packets. TCP program divides the message into a stream of packets that are being sent to the receiver and then reassemble these packets into complete message at their destination. IP addresses each packet and routes the packet across different nodes and through different networks before they arrive at their ultimate destination. Let us take a simple example to understand TCP/IP. Suppose Mr. A wants to send a message to Mr. B. Message consists of 2 pages. Further assume that 20 packets are required to send a message of 2 pages. First, TCP divides the message into a stream of 20 packets. IP writes the address of sender and receiver on each packet. IP throws these 20 packets on the internet. These 20 packets take different available path as determined by router. These packets moving through different paths of different networks reach to the destination computer of Mr. B. Lastly, the TCP program on the computer of Mr. B reassembles these packets in required order to make it a complete message. Look at this particular example. We have sender computer and receiver computer. There are number of networks and in these networks we have bridge and we have this blue disk is router. So there are different networks and in these different networks we have bridges and in order to interconnect these networks we have routers. This sender computer intends to transmit a particular message. This red blinking line shows that this is a packet of message. This message goes to the bridge. Bridge transmits this message to a router. Router sees that which particular network path is free. At present it is in network 1 and the router finds that in the network 2 the path is free. So the router transmits this message to network 2. In network 2 this particular message reaches to bridge. Bridge transmits it to another router. Routers find that the third network is the path in the third network is free. So the router transmits this particular message to network 3 bridge. Bridge again transmit it to another router and router finds that the path in the network 5 is available. So it transmits the message to the bridge of network 5. The bridge of network 5 transmit this message to the receiver. In this way you can see that a particular message has been transported among different networks. Message from one particular network it goes to another, from another it goes to the next one. And we have number of bridges and routers. Bridges interconnect networks and the router determines the availability of the path. Let us look at the second packet, which is in green dotted lines. Again, the message goes to the bridge. Bridge transmits this message to the router. Router finds that path in the network number 4 is free. So the router transmits it to the bridge of network 4. Bridge of network 4 finds it that another router is free which is connected to network 4 and 5. In the network 5, the message goes to the bridge, and from the bridge this message goes to the receiver computer. The TCP in the beginning divided all message into different packets, and once these packets reach to the receiver computer, the TCP at the receiver computer reassembles these packets in order to make it a complete message, and then that message is shown to the receiver computer. TCP guarantees that any data sent to the destination computer reaches it intact. It makes the processor appear as if one computer is directly connected to the other, providing what appears to be a dedicated connection. IP is a set of conventions used to pass packets from one computer to another. IP is responsible for routing the packets to a desired destination IP address. Packets are passed using three kinds of mechanism: bridges, routers, and gateways. But in our example, we have used bridges and routers. This is the photograph of bridge, photograph of router, and this is gateway. IP is a connectionless protocol, which means there is no continuing connection between the endpoint devices that are communicating. Each packet that travels through the internet is treated as an independent unit of data without any relation to any other unit of data. Then these packets of data are assembled in right order by TCP, which is connection-oriented protocol that keeps track the sequence of all the packets in a message. Internet protocol characteristics. The IP protocol of TCP/IP group is responsible for routing of all packets on Internet. The IP protocol contains information regarding the names of the sender and receiver of data. The IP protocol also defines the Internet addressing system. IP protocol is responsible for routing packets from one host to another. Note, the most widely used version of IP today is Internet Protocol version 4, that is IPv4. However, IP version 6, IPv6 is replacing IPv4. IPv6 provides for much longer addresses, and therefore many more internet users can be accommodated on net. IP version 6 includes the capability of IP version 4, and any servers that support IP version 6 packets can also support IP version 4 packets. Thank you very much.